Well, good afternoon, everyone, and good morning, good evening, wherever you are. Welcome to the first of two sessions of lightning talks from a variety of people across the software underground on very diverse topics. What's going to happen is people are going to speak for about 5 minutes on something they're passionate about, have been working on, or just some general experience. And then we'll have a small kind of technical break to hand over to the next speaker. And it's going to flow like that for a couple of hours with a break after approximately an hour. You should see on the bottom of the screen a link to the Slack channel where we can discuss, chat, hang out, and enjoy each other's companies. We're going to try not to take questions in this session and try and have the conversations on Swung or maybe connect people up because this is a bit more free form than a tutorial or a lecture. So, yeah, grab a drink, sit back, and enjoy. Handily, I am the first speaker, so I shall share my lightning talk on the topic of I guess hacking in the software underground. It's a bit of a look back retrospective on my abilities and kind of journey here. Let's make that full screen. So yeah, for those of you who don't actually know me, I'm Dan. I'm a geologist from the UK. I'm really a geodata scientist now, and I'm currently based in Stavanger, Norway. I joined the software underground in about 2018, 2017 on the back of a hackathon. I didn't know a lot about coding. I actually dropped the coding module in my degree to do more biostratigraphy. That's how little I knew when I graduated. I was very into fossils and didn't really want to touch Fortran or MATLAB or even Python or R, and kind of appreciated skills over time. So one of my big passions is Viz, and this is the route I kind of came into this game via. There's big data everywhere. There's a lot of different things we can do with it. In the oil industry, in this example, we're just looking at different plays for potential hydrocarbons. And I started playing around with pre-built libraries like this is Microsoft Sandance, which is very nice. It's JavaScript based. It's free to use. I recommend having a dig around with it. And eventually, I started trying to build my own dashboards for exploration reporting and for for kind of honing my skills. And this kind of led down the next path, which is machine learning. As the time goes on, you kind of find out that you need more data. There is missing data or there is bad data. And so there's got to be better ways to predict it. And I started off, like most people, with the Fasces classification challenge, which is what you see here. Of here are some wells. Can you use the suite of logs to predict them? It was a struggle at first to get the notebooks working and actually learn about not just writing the code but applying it. But after I got past that, I found there was more you could do, and I'm now into this world of using voting, propagation, spreading, and all kinds of weird methods that even 6 months ago I probably would have been very phased by. So yeah, I guess I'll talk about the catalyst really that got me started was a biostratigraphy project of all things. I had a bunch of slides to prepare, analyze, and report on in 4 months, and it took me that long to sit in a cold lab for 12 hours a day to cover two entire samples. And as I was chatting to the guy who was working on the mineralogy project, he said, "Oh, we have an automated system. You put the slide in, it will traverse it, and it will image it, and it will take out all the mineralogy images for us overnight." He was basically light years ahead of me, and I thought, why am I not doing this? Where where is my next route? Why am I sitting in the lab while he's off in the pub or enjoying himself? And I tried, and I ran into this error almost immediately. And thanks to the software underground, I moved past spelling pandas with a capital P and into actually being able to write decent code and troubleshoot it. It's not to say I'm ever a completionist. I don't think I'll ever be finished with the hacking. And I just took a quick snapshot this morning of the many different GitHub repos I'm working on. I tried some things with COVID-19. This is what you see here, just some random repos. Learning new modules. There's some work from here. and there's just random stuff that interested me to test and train. So my main takeaway here, and I'm just on time, is don't be afraid of it. It will phase you at first. You will fail. You'll fail fast. You'll fail well, but eventually you'll solve that problem. And if I go back to my biostratigraphy problem, this was 8 years ago I ran into this problem, and it was 1 month ago I solved it fully. So that's really my takeaway here is the software underground is a bit of a lightning rod and a catalyst, and I highly recommend just taking the plunge with something that you've encountered in your past or doesn't really seem to be solvable with normal tools. And that is my 5 minutes of thoughts. So I hope you enjoyed that. And if you want to discuss more, just ping me on Slack. I'm around pretty much all of the time, aside from the normal kind of sleeping hours for UTC. Cool. And I will stop sharing. So our next speaker is Matteo, who will be giving his talk. I know he's been rehearsing it for a while, and hopefully he's ready to share the screen. And yeah, Matteo and I have actually been working together recently on this 52 Things on Geocomputing book we've been editing. And yeah, so if you're ready, Matteo, do you have the permission to share your screen and take it away?
Can you see my screen?
Not just yet.
So are we waiting another 5 minutes, or is it?
Yeah, it's up to you. You've got 5 minutes to get the talk set up, and just if you want to add any more to your introduction, feel free. Yep, you see it. Perfect.
You see my screen now?
Yes, lovely color maps and some good stuff.
Nobody else is this live now or not yet?
Yeah.
Okay. Right. I can get started. Welcome, everybody. Thanks for attending. This is the title of my talk, a panel app to show color map artifacts. And you can see the repo here. Included a couple of links if you want to get started with panel, which to me can be summarized as putting together an app pain-free. This was what I was looking for, and it was a real surprise for me. I'll show you right away the app that I built, and then we can go back and see how it is built. There's a bit of an explanation at the top on checking perception. There is a little bit of explanation on the selector, but essentially you can select whichever you want matplotlib color map. There is a top row which is static, it's for reference. On the left you have this seismic horizon from the Panopscope 3D. You can see some nice fault traces in grayscale. In the middle, it's the gray intensity of the data. And then I run on the intensity Sobel detection. And these are the edges, sharpening and showing the faults really nicely. My intention was to show what happens to your perception when you add a color map to the mix. So on the bottom row, on the left, you have the same data, but now using the jet color map. You can immediately see, I'm hopeful, that some areas, especially in the green, are really washed out and you lose the resolution, the ability to see some of the faults clearly. This is even more visible in the intensity map in the middle bottom, which is essentially like converting it to grayscale or printing it in grayscale. And this is a bit what I was trying to simulate on the right. what I've done is I've taken the color map data and used a function to convert it to an RGB NumPy array, and then the intensity, and then run the Sobel detection on it. And you can see, I am hopeful, quite well these washed out areas where the definition of the faults, even if you run an edge detection, are lost. And I'm not trying to say that this is what happens if you run an automatic machine detection on the data, because that algorithm won't know anything about color mapping. You won't see the plot. This is what happened to your vision when you're looking at this map and trying to interpret some of the faults. You're impairing your ability to see them by using a bad color map. And there's other really bad ones like this. For example, I'll show you another example, this sniper spectral, which is a spectrum map. You see these blue areas, they're really flat, and they show up as flat areas here in the Sobel edge, and they're surrounded by escarpments, which are not present really in the data. So let's go back to this. And again, the app is built on 2 widgets and a couple of plots, rows of plots. One widget is the text, very simple syntax, a static text widget. Then there is another widget to select a color map from a list, and you can pass a default here, and then some explanation text at the top, and then it's composed as a row of 4 columns, the actual widget itself, and then 3 rows of 3 columns of text. Again, this is very simple. This is one of my workhorse functions. It does all the plotting, the reactive plotting at the bottom, and it uses some other auxiliary functions that which are not shown, which the most important one is the one at the top, which essentially, it takes the color map plot, the one it was shown in JET color map, and stores it to an RGB NumPy array, and then on that I can run the conversion to grayscale and the edge detection. And this is the only really the important bit. It's the reactive bit. It's the panel decorator. 3 lines, very simple syntax, but essentially when the color map variable is changed through the selection widget, the plots are updated, calling again that function to make the plots. That's it, essentially. Then there is a composition, which can be done in panel with a couple of different ways. One is through a grid, but I've chosen a simpler one. It's a column composed of 4 rows, the explain widget, the selection widget, and then the 2 rows of plots. And then for serving, the app can actually be served using Binder, and you can go on the repo, put the link in the chat, and start it from there, or it can be just launched directly from the notebook, which I will show you right away. It's done on the fly. And that's it, really. Responsive sizing and maybe moving away from matplotlib for speed. And thanks for listening.
Thank you, Matteo. So I have a question, if that's all right. I'll turn my screen, I'll turn my camera on so you can see my face again. So the repo, is it public and open, or is it still under development?
No, it's open. I'll post it on the chat right away.
Great. That's a very nice talk, some nice examples of color maps and how to use them. I have a question for you, is what is your favorite color map and palette?
Well, it depends on the task, really, but I always start with grayscale and then move to something like a linear color ramp, going all the way from black to white and using all colors, but with a straight lightness or intensity ramp. Yeah.
So do you think we have a problem with color maps in general in the geosciences? Do you think we have too many or too many bad ones, I guess? So I know this is
Yes, I would say there's a lot of really bad color maps.
awesome.
Yeah.
Awesome. And Justin is just loading in now. We're going to
Great.
actually spend 5 minutes just getting things set up, and we'll start again on at 20 past, just to let anyone who wants to come in again join in. But thanks so much for the great talk, Matteo, and been really fun working with you on the hackathon. So we've now got Justin, who joins us from the United States at this early hour for him. So big thanks for that. Who's good? Yep. Yeah, so I'm just going to do a little bit of an introduction here. Yeah. So a talk which I'm quite interested in is switching from a Pythonic mindset to a JavaScript mindset. Something I've always struggled with, having had front end developers around or people who are better in the JavaScript world than me. Do you want to say a few words on yourself, Justin? Kind of what drove you towards this talk and why you think it's important to share? I can unmute you.
Sure, yeah. So it's like someone who has skills in both areas. I do see people who, if they like don't like start doing a bit of like web development early, and they get like pretty far down their Python path. Everything else seems like super scary then to them, and like I've even gone to like SciPy and like seen very smart astro physicists who would like talk with like a care about like how hard it is to understand JavaScript. So that kind of prompted that sort of prompted the talk. And then also like Steve Purves was actually going to give a talk on the exact same topic in a hour, but I don't know what he's going to say. So he might say something very similar or like completely different. So we'll have to find out.
Yeah, he may have had a very different experience. There's one thing I want to say is that I really like your PredictorTops project repo. If anyone hasn't seen it, it's a really nice example of using stratigraphic picking with supervised machine learning. And Justin's got a really nice write-up of it on his website. Yeah, that's kind of how I first encountered the work you were doing, was looking for a solution to that problem myself and coming across PredictorTops. So thanks for making that and putting it out there. It's a very cool little thing. And I think we're just about coming up to on time. We've got about 30 or so seconds for me to waffle. But if you're ready to go, without further ado, I'll hand it over to a talk I'm looking forward to. I'm sure many others are, and that's Python, from Python to Java. So take it away, Justin.
Okay. Yeah, so like as Dan said, my talk is going to be on recommendations for shifting from a scientific Python mindset to a JavaScript mindset. And just as a word of warning, this is a very severe over generalization. So like take it with like a huge grain of salt. So just to start off, 5 things I tend to find myself telling people is to console log 3 times more than you print. You probably don't have to have a framework. Spend more time finding examples rather than starting from scratch, and learn by doing sooner, and don't always bother with a fundamental understanding of the package that you're using. And debugging is less about understanding your dependencies and more commonly about information flow and security. So the thing that I find interesting, what I'm going to actually spend most of the talk on though, is like, why do I find myself saying those 5 things? And I think it boils down to 2 things. One is that the packages used in scientific Python and JavaScript are built on different task types and styles of information flow. And 2, the browser is super important. So if I break flow and browser into those 5 things, this is how it kind of like maps out. So some of them are things I say because the browser is very important in JavaScript, and some of them are things I say because the flow in JavaScript is very different than Python. And I'll go a step a little bit back, and then I explain why those things map. So Python and JavaScript are different powerful abstractions, and most of the libraries you'll probably tend to use in Python or JavaScript are designed to be good at different things. And so a lot of the things we use in Python are good for doing NumPy-like things and processing matrices of numbers, basically. And JavaScript exists to manipulate the DOM, which is the direct object model. And so going on, those common abstractions affect the flow. So scientific Python tends to be linear for the most part. You set up a bunch of different configuration, and then you press go, and you process something, you predict something, you do something. JavaScript, because it works with web development, has to often be used in situations where like the user can do like 50 different things. And so the flow it is a lot more complicated. And so that affects then the style of what is included in a dependency. So in scientific Python, it tends to be a toolbox for like related tasks. Whereas in JavaScript, the dependencies are smaller and they're much more number of them, because you tend to have like a different dependency for like every different size nail, basically. And then the other thing that I mentioned was the browser. And so the browser is the reason JavaScript exists and will continue to exist. So you won't kill off JavaScript until you kill off the browser, for those who really want to kill off JavaScript. It is super powerful, runs a lot of your code behind the scenes. Compared to Python, it has 3 differences. security for free, which is both great and also not so great when it stops you from doing things you want to do. And then the other 2 points, and I'm low on time, so I'll skip to the final slide where I to explain how those 5 pieces of advice I gave at the start that I find myself saying a lot, how they map either to browser or flow. So you console log 3 times more than you print because you fundamentally don't write your code in like blocks where you get output and you see the output of each line, and so you have to like remember to console log to actually check that the code does what you think it does. You don't need a large framework because those frameworks are for when the tangled when a flow gets very, very big. And so they are high-level abstractions which help solve that problem, but most of the stuff geologists writing JavaScript are not big, large, complicated pages. They're small things. And so if you spend a lot of time trying to pick up a framework, you don't need that framework, so it's not a good use of your time. And then you spend more time finding examples, and that's a good thing to do because JavaScript doesn't you need to have a server to that you have to find and pay for and set up, etc., to have a live example. So there are a lot more examples of most of the things you want to do in JavaScript online somewhere. And so, for example, I write a lot of D3 code. I have never written D3 from scratch, ever. I always find an example and start from there because that's always going to save you time. And then learn by doing sooner in JavaScript because the fact that the flow can go in a lot different places means that it's hard to define a single path to learn things in JavaScript often compared to Python. Huge generalization there, but mostly true. And then because you write JavaScript and then talks to your browser, you get a lot of developer tools and such for free. And so these are very useful things to help you check your code and debug your code. So definitely try and pick them up relatively soon. And that's my talk.
Fantastic. Thanks so much, Justin. I have one question, and that's what's really exciting you right now? It could be in JavaScript, geology, or just in general. What's capturing your interest?
So one thing I think is cool is that it's starting to not be super hard to get Python and JavaScript to talk back and forth in a notebook. And that's still sort of hard, but it's getting better finally, I think.
Fantastic. Okay, great. Well, thanks again. Justin's also leading a hack on well visualization in JavaScript and has been giving advice across the board on other projects. So yeah, please connect with him if you've got questions or you want information. He's an invaluable resource in this world. Jesse has joined us next, another US friend. So while he gets set up, just going to, yeah, fantastic. Good morning.
Good morning, everybody. Let me share my screen here. All right. All right. And are you guys ready?
We are always ready and waiting for you. You can take it away and we'll have a little catch up after the show.
All right, sounds good. Okay, so this morning I'm going to talk to you very briefly about why machines won't take your geoscience job just yet. So to begin with, who am I? So my name is Jessell Pisel. I am an assistant professor of practice here at the College of Natural Sciences at UT Austin. You can follow me on Twitter at GeologyJesse or on the Software Underground, Jessell Pisel. And since I'm talking about machine learning, I figured it would be appropriate to put everybody's favorite blue and black kind of brain AI thing in my talk, but I figured I couldn't decide just on one of them, so I just grabbed the entire Google search of images to throw on here for my cover slide. So this morning, I'm going to start off with my argument that machine learning will make our work more interesting and really eliminate the boring things. So what do I define as boring things? Well, I consider munging and correlating well logs, planning well trajectories, and ultimately interpreting geologic features are kind of what I call the boring things. So this morning, I'm going to give you 4 examples that are definitely biased. The first example, we're going to talk about well log mnemonics, some of our current work here at UT. Then I'm going to talk about well-to-well correlations, and there's been a lot of work from researchers on this topic lately. Then I'm going to talk about reinforcement learning for well paths, some more of our work. And then lastly, I'm going to talk about qualitative data interpretation. And you guessed it, it's more of what we're doing here at UT. So first off, let's talk well log mnemonics. So the problem, well log LAS files are pretty dirty and they use a variety of mnemonics for the same thing. So for example, gamma ray, GR, has 478 matches when you search through a big company's dictionary. So our solution to this problem, rather than going through by hand and finding all the gamma ray logs, that are GRGC, GR, gamma ray, gamma, we're actually building out a package that uses dictionaries and keyword extractors. It covers about 80% of the cases that we run across. So it covers a pretty large swath of the well log mnemonics. And then we're using a classifier to cover the last 20% of edge cases. This package is coming out this summer, so that way you can load up your logs, run them through this, it'll alias everything out, and basically standardize your entire field's suite of well logs to kind of whatever standards you want. Next, let's talk about correlations. So correlations, the problem is that it's time consuming and it kind of appears to be the standard internship or new hire experience of sitting in your office and picking tops for a while. So the solution to this one, a lot of people have been working on this lately from like what Justin, the previous talk, he had come up with predicted tops where he's using an XGBoost model to correlate logs. And then there's all kinds of dynamic time warping exercises out there that are really great. So this is saving a lot of time. Next, let's talk about well path trajectories. So the problem is that for unconventional wells, they're just coming in and putting in cookie cutter well paths based on previous wells and leases, not on the rocks or reservoir models. So our solution is we're using reinforcement learning to optimize well trajectories, more or less in a pre-drill setting. So what we're doing for this is my students are working with OpenAI. So they've got an agent and an environment. So the agent is the more or less the drill bit, and the environment is the oil field class that they created. And the agent interacts with the environment, going through collecting oil from different cells in the reservoir model. And what's really neat that they found is that in 2D, they do pretty well. And they've actually discovered that in 3D, the reinforcement learning agent does as well as humans. They couldn't do it any better and predict a better path on their own. So that's pretty promising. So that's going to get rid of kind of the more boring things. Lastly, I'm going to talk about geologic interpretation. So the problem is, can machine learning interpret geologic features? Well, so this is something we've been working on. We built out a conceptual geometric model, trained a classifier on the model, and we're having the classifier make predictions. And the results are really interesting. So this is based on well log data out of Wyoming. And what's really unique is that everybody kind of looks at this as a 2D problem, putting together cross sections, that sort of thing. Whereas in this setting, we can actually do things in 3D and see different stratigraphic geometries from horizontally stratified to on-lap to truncation geometries. So the machine learning model is really augmenting what we're able to do as geologists and aid our interpretation. So it's kind of a guided interpretation. And what's really neat about this is we've got 50 years of geological literature from outcrop and subsurface studies to back up the classifier's predictions. So lastly, in conclusion, machine learning is very useful for automating the boring things and assisting with the more challenging things. What does that mean? Well, it frees up geoscientists to think about these higher level problems and create custom solutions. So for example, my undergraduate researchers this summer are focused on data imputation, information theory, and generative networks to speed up data set construction and model building. So my takeaway from this talk is, as this technology ramps up, the easy to automate jobs will disappear and the higher level cognition and interpretability jobs will become much more in demand.
Fantastic. Thanks. Great. Just for anyone who's not aware, OpenAI is famous for beating human players at video games, human players who win a lot of money playing video games. So it's really interesting to see it applied to the oil industry. Same question I asked Justin is, what's exciting you right now in the space? What's got you and the students passionate about coding or geoscience, or it could be anything, but what's really holding your attention?
Yeah, so I think right now generative networks are kind of definitely keeping my attention. The applications of either style transfer or more or less these kind of creative things where you're generating from previous examples seems to be kind of a really, really promising area. We had one team that was looking into generating, more or less training a neural network based off of all generated images just to see how it did. I think that'll be a very, very interesting thing going forward, kind of seeing if these machines if these networks can learn to construct kind of concepts ultimately.
Great. Well, thanks again for your time this morning. Enjoy the rest of the day. And yeah, Jesse is also famous for his X lines of Python repos. So if you want to learn something quick and fast, check him out. I always learn something new. And Martin, hopefully his presentation is all uploaded and he's getting ready to go. So he joins us from South Africa and will be our next speaker. Harvesting some facts this morning about the oldest rocks near to everyone in Swung. So we're working on compiling a global stratigraphic chart. I don't know, Martin, can you hear us okay?
Yeah, I can hear you all right.
Great.
That's entirely incidental to what I'm going to talk about. I just happened to notice that I was near some walls.
So Jesse, I'm going to move you back to the waiting room now, but thanks again for your time. And yeah, we'll catch up with you later. So Martin, how long have you been with Swung, I guess? How did you first come into the software underground?
Through Matt, when I started talking to him on Twitter back in 2010 or 2011-ish. I don't remember when I actually joined Swung, but I think it was fairly early on. Yeah, I'd have to actually go and look. Probably around 2015, 16, somewhere there, I guess.
Okay.
Long enough that I don't remember.
Yeah, I was going to say you were part of the furniture when I joined, so it was obviously quite in the old hazy days. What will you be talking about today?
I want to write a book, and I might need some help, but I can show you what I've done so far. Let me share a screen.
Fantastic. Yeah, we've just got 1 minute till we can start formally to let anyone who's not here yet catch up, but to give you enough time to load your screen up and maybe introduce yourself more fully.
Yeah.
I'm glad it all uploaded okay though. I'm glad the hamsters were able to run.
I managed to push the anemic hamster in the router fast enough. longest upload of 30 megs ever.
Fantastic. All right. Well, I'm going to
So-
shut off and hand over to you.
Okay, cool. So yeah, my name's Martin Bentley. I recently finished a master's in geophysicsy type stuff in South Africa, specifically in Port Elizabeth. And yeah, something that I realized coming out there with some of the first years that I was working with is that there isn't really a concise location, especially online, to describe the geology of South Africa. So I had a look around, and you can find the information is available. This is a leaflet map that I put together using some data from the Council for Geoscience. And my goal initially is, just get an idea of what the geology of South Africa is, split it up by supergroups, for example. So we can have a look and say, all right, well, here's the Karoo supergroup, and I just grabbed this out of what I'd written already. And one of the nice things about if you're doing stuff digitally is you can start messing around with interactivity in your book or in your page. You don't just need to have a single static image. And if you're doing it right, you can also make it fairly responsive in terms of, okay, now this is, somebody who's got an iPhone, they see something that looks more or less like this, but they still get everything else. And, if you've got somebody and you could actually then get locations or whatever, figure out where you are and what the geology around you is. But at the same time, people want print copies and everything. So one of the things that I found was a tool written in a Lisp variant. It's written in Racket. It's called Pollen, and it allows you to generate a bunch of stuff at the same time. So here's a PDF generated off exactly the same code or the same written stuff. And you can see that interactive map has changed to a static image because, you can't really have an interactive map in a PDF that is intended to be printed out. But it looks quite nice, and you can do bibliographies and side notes and things like that. And the code itself is actually relatively simple. So once you're actually writing, if you're writing the actual stuff, so here is a section talking about the Cape supergroup. It's very unfleshed out at the moment, but the idea is going with this. I took this to the head of the research institute that I'm with, and he said that wasn't being nearly ambitious enough to just go and describe what geology is or what the geology there is. So I put together a proposal here for essentially needing a new textbook for geology. Make it digital first so that people can access it with cell phones and whatever else they've got. They don't have to print out. They don't have to have a dead tree copy lying around somewhere. But you also need things that depend on the geology. It's a foundational science. So, soil types, vegetation science types, agricultural potential, groundwater, especially in South Africa, the latter two are increasingly important. And, part of the idea here is that if we can get something licensed and we can start pulling in these things that are intended for the social or that have social impact and social relevance, you can essentially start looking at a new type of geology curricula where you need to cover, where you want people to understand the basics of geography and geology, but they also need to understand social science. They also need to understand the ethics behind doing certain things and how things are done. Things like the resource curse that exists in Africa. And I was chatting to other people over the week, and, it's in South America as well, where we've got huge amounts of resources, but they're all being funneled elsewhere. And in order to grow homegrown sort of or to grow potential that's at home, you need to have people who understand what's going on. So yeah, if anybody knows people who would be interested, especially on the stuff that I'm not an expert in, I mean, I'm a geologist and I can cover a bit of geophysics if I talk fast enough and people aren't listening quickly or carefully, then I can do that. But it needs political science input, it needs social science input and things like that. And I think that could be quite a valuable contribution going forward. And if you can get something like pollen set up, it becomes quite easy to do it as Markdown. You can then push a static website quite easily. That's relatively low cost. I've managed to figure out how to do those interactive maps that become non-interactive without any particular input from the user. So I think the technology exists to do something like this. And, you know, maybe pollen's not the best, but we can do something quite cool, I think. And I think it's worth doing. So yeah, that would be my 5-minute pitch for a new book and a new geology curriculum.
Yeah, I think it's a great idea. Obviously, in the current discussions that's going on everywhere, I think geology curriculum that's much wider and covers the actual influence is really important. I know in the UK especially, geology students are dropping in favour of other subjects. So when you're not working on the book, Martin, what's kind of your other horizons? Well, what's holding your interest?
Well, this week has been a mad blur of doing random stuff all over the place for Transform. So I've been jumping into a few different projects to chip in here and there. I'm quite keen on the workflow examples one and the Gostin one. We're pulling stuff together. We'll have to see how much time I can put towards those, but those are quite exciting.
Great.
Yeah.
Well, hopefully there's some people who can help you out with the other bits of the book or have connections. And yeah, I've seen. I'm always excited by good viz and interactive maps. So, and I know I'd definitely read it if nothing else. So you've got at least an audience of one. But thanks
I
again.
mean, it's yeah. Thanks very much. Have a
Yeah.
good one.
And our next speaker is here. So I'm going to move you back to the waiting room, and I'll speak to you later. Hello, and welcome.
Hello, everyone.
Yeah. So, how long have you been in Swung, Jan?
Actually, not too long. So I'm a PhD student. I recently started in Aachen, and I joined like maybe a year, 1.5 years ago during my master thesis. And I enjoyed it a lot, actually. It helps.
Fantastic. So, what will you be speaking on today? What your 5 minutes of fame are?
Yes, I will actually talk about something from my master's thesis, which is maybe a little more technical in the direction of geostatistical modeling. We actually had a great tutorial by Michael Perch on Monday in this direction. So for people who follow that, it's kind of in this direction.
Yeah, we just got a couple of minutes before we can start. So if there's anything else you want to plug or any more kind of an introduction you want to give, feel free, or else I'll go back to my question list.
Oh, shoot.
Yeah. So what have you been doing to keep yourself occupied in lockdown other than writing code? How's it treating you?
Actually, a lot of sports also, and obviously also because I work at university now, we've done teaching, which was a challenge, obviously, but also really fun during these times. Changing the usual a little bit and trying out new things online.
And how is the new technology treating you? Are you finding that Zoom is replacing the classroom, or?
Obviously not, but it has some upsides, I guess. So I felt like, for example, putting students in random groups together instead of they choose groups as they like in the classroom help to kind of get different people together when they work in like group work or stuff like that.
Okay.
And that's actually an advantage, I guess.
Okay. Yeah. So when you're not working on your geostatistical modeling, is there anything else, any other burning passions or anything you've read recently that's cool?
I mean, I just heard in I think it was 2 talks ago about the style transfer, and we have played around with that a little bit too here in Aachen, and it's really interesting also in the direction of like maybe doing field trips. Obviously, virtual field trips now is a big topic, and we were thinking if we can fool undergraduate students with like style transferred images to make them believe it's real outcrops. So if anyone is working on that, would be very interesting.
Yeah, there's I don't know if he's around, but Hallgrim and I discussed this similar thing over many beers, making fake core logs and seeing if anyone could tell.
Exactly.
Yeah. Great. All right. Well, I think we're just about on time to start. So I'm going to hand it over to you for 5 minutes and then we'll catch up at the end.
Perfect. Thanks. So as I said, this is about geostatistical modeling and specifically in deformed domains. And again, just some recap on geostatistics. What do we want to do? So the basic assumption is we aim to model the distribution of a property, in this case in the subsurface. And to do that, we assume some kind of spatial correlation within this property distribution. And we use distances between known and sampled locations and unknown locations where we want to estimate our property. So distances play a very important role in this whole process. And I created a small model I want to show now. So actually this model done with GemPy, also another nice tutorial we had on Tuesday on GemPy if you want to learn how to create a model like this. And if you now look at this model and assume that the red layer here is our domain of interest, so we are interested in the property in this area, we can see a bunch of structural features. So we see that there is actually folding, obviously, all over the domain. Also, we have an unconformity on the top where basically a part of the layer is eroded and missing. And we also have a fault at the side here with a small fault offset. So those are all structural elements that are kind of important in this domain. Now, as I said, we talk a lot about distances. And if we look at any 2 points in this domain now, so let's consider these 2 points that are quite far away on different sides of the domain. There's different ways to define the distance between those points. The easiest one, and that's the one that's used obviously the most, is the straight line, often called Euclidean distance, just between those points. Maybe as the bird flies, you would say in German. And obviously, if your property distribution that you're looking at developed after the whole structural deformation of this domain, this is a reasonable distance metric to use for your geostatistical endeavors. But if your property distribution instead developed before this whole structural evolution, you can either obviously do a very complex, I don't know, restoration of the domain, but we can also just try to use a different distance metric that accounts for all those things. And I just drew it in here, just literally. So we follow kind of the geometry of this layer. And also we account for the offset, this basically should be neglected, and also the unconformity. So because this is a lightning talk, obviously, I don't want to go too much into how this algorithm works. We basically use the scalar field that GemPy provides. If you're interested in that, again, maybe check out the tutorial. But when we compare this now in a cross section, I will first now show the Euclidean straight line distance, so this dashed line here. So if you look at cross section and we take 1 point, in this case, in the left side kind of, and plot the distance field from this point. If we look at the Euclidean distance or the straight line distance, we basically gain a smooth circle. The distance is smoothly increasing with distance from this point. And the geometry of the layer or the domain is neglected, basically. So we could put any geometry in there. It wouldn't matter. We still have circles, basically. Also interesting to note, maybe the maximum distance. I mean, I have no real units here because this is a theoretical example, obviously, but 1,700, around that. Now, if you look at what we did, or this alternative distance metrics, and there's a lot of approaches in this direction, we see now that maybe starting from the left side, actually, where the folding is strong, you can see that this distance metric kind of bends around and follows the geometry of the layer. For the part of the unconformity, we actually see that this part that is eroded is still incorporated in the distance calculation. And also the fault offset is neglected in this case, which allows us to basically get a simplified version of the undeformed state of this domain. Also, again, to compare this distance, the maximum distance here is a lot higher with like 2,400 or whatever. So this gives us actually a possibility, a simplified possibility to account for this deformation in our geostatistical modeling, which is really nice. And that's what I've been working on in my master thesis. Maybe if I still have a second, so there's still some issues with like robustness and very complex situations. And also we are working on putting the code really open source, maybe as part of GemPy. But yeah, so this is what I wanted to show today. Thank you.
I'm still muted because I wasn't expecting you to finish exactly on time. So that's
I did it.
Well done. Yeah. So I don't really have many questions. I think we're going to head into a 5-minute break before the next hour of sessions, led by Mark Jessell, who's been sitting here patiently from Australia in the waiting room all morning. But yeah, guys, always great to see stuff in GenPy. So funny enough, I first got introduced to GenPy the last transform, so it's a real, really interesting to see, and I can't wait to see what happens when you move away from Fiano at long last.
Oh yeah.
Because that to me was a big problem.
We
But yeah,
can't either.
yeah. So yeah, hopefully everyone's enjoyed it this morning. If there's any feedback, please feel free to dump it in the Lightning Talks channel, and we'll see you in 5 minutes for the next talk. Okay, welcome back to our afternoon hour of lightning talks, closing out the sessions for today. I'm going to hand over to Mark, who is up way past his bedtime in Perth, Australia, who's going to talk to us about Map to Loop, which from the title slide looks amazing. So Mark, take it away.
Hi, yeah, it's all marketing. Hi, I'm Mark Jessell. I'm from the University of Western Australia, which as its name sounds is in Western Australia. I'm a structural geologist, and what I'm talking about is part of the Loop consortium developing 3D modeling technologies. It's also part of MinX and it's also part of DARE, but I won't go into those details anymore. What Map to Loop in particular is trying to do is to deconstruct vector geological maps so that we can get unbiased inputs for 3D modeling. So the dream is to be able to draw a rectangle around a bit of geology and have a 3D geological model pop up without having to cheat too much. And so the examples I'm going to be taking are from Western Australia, from the Hammersley district. So they're complex geology, but not crazy complex. And we can get the data from various online servers, or we can just do it from shapefiles as we wish. And once we've got the data, and the data that I'm talking about is going to be bedding measurements, so structural observations, faults, polylines, geological polygons, the DTM that we can get from any number of servers, and the topology that I'll talk about a bit later, but that's something that we derive, it's not a primary input. So the idea is that we can take our structural observations, combine them with the geology and combine them with the DTM to get X, Y, Z, dip direction, that sort of structural information. If you're not a structural geologist, you're going to hate this talk because that's what I'm going to talk about. We can get the stratigraphic basal contacts by combining the DTM, the faults, the geology polygons, and the topology. And we can get the faults themselves, obviously, by combining the DTM and the fault lines. So we're getting real 3D information. It's the sort of thing that a lot of software packages, 3D modeling packages do anyway, but we have more control over what's going on. And we can also bring in sections from various different interpretations. With this basic raw data, then, we can do a number of derived structural outputs, such as looking at the structural analysis for particular stratigraphic units. We can estimate which side is the downflow side on faults based on the faults themselves, the geology and the local structural bedding information. We can make estimates of the displacements on these faults, and we can make estimates of the local formation thicknesses. So those are all sort of structural geology things that we can get out of it. We can also get stratigraphic information. So based on the polygons, we can sort the spatial relationships and whatever temporal information there is to get these sort of network diagrams where the arrows are pointing from younger to older horizons. And the colors of the arrows are telling us what type of contacts there are, so stratigraphic, fault, or intrusive. We can also look at the spatial relationships and the apparent age relationships of different faults, so we can see which faults are cutting which ones, which are the most important faults in the area. And we can combine these two types of information to see which stratigraphic horizons are cut by which faults. We take all of that, and that's essentially what we need to build a 3D geological model. So we can then pump the outputs from Map to Loop into 3D packages such as GenPy, which is developed by Miquel de la Vaga, who you all know well, into commercial packages like GeoModeler, into Loop Structural, which is Lachlan Gross's baby, and which is going to be released open source quite soon now. And even, thanks to Noe Pollock, some parts of it, the fault networks can be exported into Noddy, because if you have a 3D talk without Noddy, then what are you doing? So the project goals are to speed up the process of developing prototype 3D models, importantly to allow reproducibility from the raw data, so it's not just what the geologist thought when he was sitting in front of the computer that day. And it enables us to clearly separate the primary observations, the derived information, the interpretations and the conceptual priors, which you need in the end to build a 3D model in under constrained terrains. So that's all I have to say. It's available, it's open source, it's on GitHub. When it crashes, you can email me or complain wildly. Don't look at the source code. It's being rewritten at the moment by somebody that knows how to program. Thank you, Johan. And but feel free to amuse yourselves with it. And I think my 5 minutes are up, so I'll stop there.
Perfect. Yeah, I just want to relay one comment from the Slack channel from Matt Hall, which is when you said at the outset, all we're trying to do is grade 1 dark magic. Yeah, so I found I think that amused everyone. So really nice to see an ambitious project taking shape. And refactoring code is always the neck breaker. I think everyone here has had that kind of experience. So I'm going to ask you the same question. Other than what you're presenting here, what else is capturing your interest right now in the wide world of computer and geoscience?
I think what's exciting me is seeing the project starting to come together. And so this is part of the Loop consortium, but we work closely with the guys from GenPy as well. And there's things like ScriptLog. And I think that we're building no one of these tools is going to solve all the problems, but we're building a community that's, well, when I say we, you guys are, because I'm just a sort of Slack stalker, really. You guys are building a community that's actually going to solve a lot of these problems. So I think just that community is probably the most exciting thing.
Fantastic. All right. Well, there's one other question actually. This is all out there? Would you, if people are interested in hacking this weekend, is this something that you're on board with?
Yeah, absolutely. Yeah. As long as they don't laugh at the code, they can do what they want with it. And if people are interested, I can go through one of the notebooks, one of the long and complicated notebooks, to explain what all the dark secrets really are behind this black magic.
There you go.
So if people are interested, they can contact me and we can set up a time.
Fantastic. Well, there's a great offer there to peek under the hood of something that in 5 minutes is impressive. So, but thanks for staying up so late, Mark, and giving us your attention today. Wesley's here, so I'm going to move you back to the meeting room and we'll try and get the next speaker set up. But yeah, take care.
Thanks
and I'll
for
speak
everybody.
to you soon.
Cheers.
Bye. All right. So Wesley, are you here? Are you getting set up okay?
Hopefully I'm here. If everyone can hear me fine.
Can see you. Your neck's disappearing into the background a bit, but other than
that, I'm too white.
Yeah, not enough sun. Yeah. So how are you today? You good? Ready to go?
I'm hopefully ready to go. Just need to share my screen.
Once again, got a couple of minutes to fill. So how long have you been on the Software Underground?
I joined a while ago, but I didn't really get into any projects. And I've been meaning to get into more open sourcey projects and stuff in general. So I mean, this transform kind of like landed right at the right time. We're trying to help out some channels, different things, helping on hacks. Yeah, but I mean, it's been pretty recent in reality in terms of things. I've definitely been one of the ones that just jumped on for this conference. I'm glad to see the communities going forward.
That's great. It's nice to see. I'm guessing from the title, you're more on the computer science side than the geology side of things, or what's your background?
So I went to the French National School of Geological Engineering. So I'm a geologist, but I specialized in numerical geology, and I've ended up becoming more software down the line. Especially like during these talks, I realize I'm not a geologist anymore with all the terms coming out. I've got no clue what they're talking about anymore. But yeah, no, I was a geologist. I would still like to be a geologist, but I've definitely been doing more code recently.
So if I throw a rock at you, could you identify it?
If it's an easy rock, nothing too complicated, we should be good. Like I can get the difference between metamorphics and sedimentary, but I'm not going to be a mineral geologist.
No, my old tutor had a thing of smashing bricks up and making them look like rocks and giving them to undergrads and said, "What is this?" And no one ever guesses brick. But that's a good prank. If anyone out there wants to prank a geologist, give them a brick that looks like a rock and watch them go nuts. But
my speaker view. button.
Perfect.
There you
If
go.
you go back to the first, click on the first tab.
That one? No,
No,
no.
first on the left. Yeah, there you go. Perfect, and just stick it somewhere. And it is 10 past the hour, so I'm going to hand over to you for 5 minutes, and then grill you at the end.
Cool. So this afternoon, or depending where you are, I want to tell you a story, and it's actually a true story that happened to me when I was coding and working with geologists a bit more. So in the company I was working with, we were a software company, and there was geologists internally, and we'd quite often get someone come up and go, "Hey, I've got this really cool idea. What if we could?" And then you knew something bad was going to happen. But it generally ended up in creating some sort of script, which we'd run once, and then the geologist would go, "Oh, this is actually really good." Is either we work on it further, or but they wanted to run it on their machine. So to get it to run on their machine is we'd package it up into this like Python file and give it to them. Then we realized that geologists don't generally have Python installed on their machine. So we'd get that installed, and then that would be that. Then after a few projects, is the geologist would probably come back and he goes, "Yeah, one of my projects isn't working anymore. Everything's kind of broken and nothing really runs anymore." This was generally due to differences in libraries between different Python versions and things like that. So like we as developers we'd more work with just using virtual environments, so each project was separated, but that's not something geologists do. So some of the benefits to begin with, like the first step was getting virtual environments on the machine. So this allowed us to separate each project into a virtual environment for that project, meaning that they wouldn't interact with each other. For tools like Anaconda, there is some sort of UIs that are available for geologists to sort of create these environments, which is kind of nice, but it still meant that the geologist at the end of the day had to install this bit of complicated sort of techie thing. They just wanted it to work on their machines. So after hitting like the wall between the geos and the devs after a while, you kind of like, okay, well, we'll just leverage sort of like the web-based architecture and have a server that runs on my machine. I'll just spin it up, and then you just got to connect to it, and then that'll just work. That worked for a while. So the geologist no longer has to install the latest scripts. It's easier to deploy and maintain the different versions of the scripts that are floating around. But this also means that the geologist has to know the addresses and the ports where all these things are running. And it kind of relies on as well is that the dev has his machine on the local network all the time and doesn't switch it off or doesn't reboot it or doesn't nuke it for some reason. So it's still not ideal, but we're getting there. So like to get around this sort of problem is we came across a really cool project, which is called Portainer. And it pretty much gives the ability to using Docker to create like an app store sort of interface. I just wanted to quickly show you what this could look like. So the geologist would just log in. So here I'm just going to log in to my Portainer that I set up locally on my machine, but this can be deployed anywhere. And we can see that they've been allocated some sort of stack. And then in here is we got all the templates, so we can just like start looking through the different templates. In here it's just like it's like our app store sort of idea. So in here I just created a nice little easy one that was called Jupyter, and we click that, and they've just got to deploy the container, and their app is up and running on the server, and they just connect to it. There we go. So we can see it's up and running here, and they just connect to it through the published ports. And there you go, they've got their app up and running with nothing installed on their machine. They can pick and choose what they want. So this is kind of like, I've heard some talks earlier talking about JavaScript and moving sort of the stuff to the web. I thought this was like a nice little tool that just allows people to interact with prototyping code, these sort of like little one-offs in an easy and distributable manner. So the pros of this is we can deploy this anywhere. This could be running on a local server. It could be running in the cloud. We've also got that UI to look around that sort of allows people to pick and choose what they want to do. And this is kind of like the approach we settled on in the end, and it seemed to work quite well. Yeah, so I mean, that's all I got to talk about today. I've left a few resources here. The slides are on GitHub. The comics were generated with this little cool tool on cmx.io, where you can just like generate your little comics. And yeah, that's it for me.
Great. Thanks so much for a really interesting talk. It always makes me think of hackathon projects, and when you revisit them months later, nothing works for whatever reason. So maybe there's something there for containerizing our hacks a bit better. It'd be nice to have an app we could just access all the past hackathon projects together. But who knows? So I'm going to ask you the same question I ask everyone, and that's, what are you what's really interesting you at the moment? What's grabbed your attention in the space lately?
I've been excited to see how far all these open source projects are like getting on, and especially like this the GeoSTIN project, where like start getting some interaction between them. So rather than having just these one-off projects that kind of do their niche thing, is having a interactive ecosystem, I guess, which I think is going to be really cool and really useful in the future. So rather than just having researchers and people that are very code literate, is start getting some of these tools in the hands of the wider audience, I guess. Because I mean, there's some really good stuff out there. So I mean, it needs to get in the hands of the right people.
I guess devil's advocate question is, how literate in code do you think a geologist needs to be now? I mean, like, how far do we need to come?
I mean, there's the difference between the code itself and creating the UI around it. So I mean, if there's these geologists now that can start, like, not every geologist needs to know how to write JavaScript or Python. They need to know how to interact with it. So I mean, it's up to the person that's writing the code to produce usable UI and UX for everyone else. And if these projects, rather than just being lines of Python, is actually start wrapping UIs and easy deployments around it, is like, rather than just being the people, like the one geologist that knows how to code, is you can start having every geologist using this tool, all the different tools out there. So that's yeah, I'm excited to see that moving forward, and moving the people, like the code getting easier and easier to use as an API for just like someone that is code literate. But with those APIs around, is we'll be able to have start building interfaces on top of it and start building tools that are usable by anyone.
Fantastic. Thanks so much for your time, and I'm really glad you're enjoying Transform and on board. Obviously, you've been heavily involved in the hackathons as well. I've seen you crop up with some repos and what have you. So yeah, guys, reach out to Wesley with any questions. And yeah, so Arthur is now here, so I'm going to shuffle you off. But have a great rest of the day, and enjoy the rest of the talks.
Yeah, thanks everyone.
Cool. Good afternoon, good morning, or good day, Arthur. How are you?
Good morning. Still,
morning.
I'm in Brazil time.
Fantastic. And how long have you been on the Software Underground?
Let me think. Maybe well, actually less than a week. I think it's since last Friday.
Okay.
I talked about it during the hackathon Zoom sessions. I don't exactly remember how I found out about Transform and consequently Software Underground, but well, I'm here.
Big step. First ever one to give a lightning talk as well. I don't know many people who would do that in their first week, so I'm excited to hear what you're going to be talking about today.
Yeah, thank you. Well, we still have a couple minutes.
Yeah.
Let me start sharing my screen in case everything goes wrong.
Yeah, in case it goes a bit wonky. So, so well, I guess you can introduce yourself while we're here. But it seems you're ready to do that.
Okay, well, I'm Arthur. I'm a geologist from Brazil. I'm currently working at software development. My work mainly consists of implementing stability analysis algorithms, mostly for soil now. But my academic research is more related to structural geology, remote sensing, and geostatistics. Oh, sure. And I'll drag it to the other way. So is it better now?
Yep, it's gone. We can see your display clearly. We still have about 60 seconds. So if there's anything you want to plug or vamp on, or anything you want to share before your talk, feel free.
Yeah, I hope that hopefully everything is set up and nothing will break during the presentation. Actually, the last tab is about something that I wanted to do, but thanks to stuff happens, I couldn't. Oh, it's 11:20 now, according to my clock, so I will
yeah,
start.
we'll hand it over to you and catch up at the end.
Well, hello again, everyone. My name is Arthur, as I already said. This is my GitHub personal page. It has this circle on the left. I'd like to talk about, I couldn't really think of a title, but basically cool stuff in geology you can do with JavaScript somewhat easily. When I started having the idea of building a GitHub page, I thought that I should try to do something a bit different to, well, just be a nice page. So I tried to learn a bit of JavaScript, and using that and the amazing APIs that we have available nowadays, I built this page here, which when viewed in a phone will work as a geological compass, but with a stereo net display. Afterwards, I moved to, this is still my main page, but then I had the idea of building something that you could use as a teaching aid. Phone compasses and accelerometers are, they can work okay, but they can be somewhat funky and lose their calibration. So I wouldn't completely trust one for field work, but it can be great teaching aids. A geological compass is quite a big investment, I think that especially for students, but almost everyone has a smartphone nowadays, at least here in Brazil in the university context. And most of them have compasses and accelerometers. And the idea is that you can go to this page. It's I'll send it on the Slack channel afterwards. It's ggcomp.search.sh. The name is tributes to both German geological compass manufacturers. ggcomp follows the basic naming convention from Gosses, and the compass lock button is imitating compasses. Well, it's not showing anything right now because this page is to have something to make it easier to teach students about stereo nets. As I remember from my time learning structural geology, it can be a bit of a foreign concept at first. You see those lines going everywhere, and then you have to draw those circles and points, and it doesn't necessarily make sense at first. So I thought that by adding an interface, but expanding on the idea of using our phone as a geological compass and using some other really interesting JavaScript APIs, we could use something that allows us to transmit our orientation data from the phone to the computer. I have another tab open here that, well, it manages to crash. Just for this presentation, maybe it's something to do with Zoom. But the idea is that when you connect your cell phone to this page, by either opening the link that appears here or scanning the QR code, which follows the same link, you will see that the stereo net moves automatically. I'm not sure if I have enough time, but try opening it again. And hopefully it will work. Let's see. So it turned into a live presentation now. And maybe, oh, okay, so that's it. The idea is that you can have the page and project it on a board. And with that, you can show your students using your phone on larger planes and stuff like that, how the orientation affects the plot of the great circles and balls on the phone. Going a bit faster, I made a really small JS library to plot stereograms using this. It's called altitude.js. It's a bit incipient at first, but it's cool that you, thanks to that, you can do stuff like building an access queue for structural geology. currently is only in Portuguese, so I'm not sure if it would be useful for anyone. And lastly, altitude is altitude. The JS is based on altitude.py, which is the main, which is the numerical engine for OpenStream, which is my, I think the project, a large project that I'm currently aiming for. I think it was a bit overrun, but that's mostly story for the time.
Yeah. I really wish these tools had existed when I was a student. This is all I'm going to say. Stereo nets and compass plotting was a nightmare back when I studied, and having an open source library to do it would probably be significantly better.
Yes, me too. Oh, there was some open stereo is. My professor started open stereo when I started studying geology, and then I became the maintainer 2 to 3 years later. I remember that one of my professors tried to give an exercise in structural geology so that students couldn't use plotting software. So he had an exercise which had many different stations mixed up for planar structures. So that's why I started a part of Altitude, which is the parser that tries to understand all these different notations and then input them. So nowadays in OpenStream, you can have basically you just have to tell it if it's direction and dip or dip direction and dip, and it will figure out the rest. So thanks for a professor trying to stop us from using software. I wanted to, the library that I'm using to make this communication between the computer and the phone is not so reliable nowadays. So I wanted to make another version using Glitch, but Glitch is totally glitched out today. So I had to already way over my time.
Yeah, we're just losing you at the minute. So I think you've got quite a lot of demands on your bandwidth with the live demo. So thanks so much for committing to Transform. You know, I think it's a big thing to do a live demo on your first ever Transform out here in a lightning talk. I don't know anyone else who's done that. So you've kind of broken brand new ground.
Yeah, thank you. I realized in retrospective that it was probably not a very good idea.
I mean, people will remember you, and people will remember the talk. So expect to be a known entity on the Software Underground now. So
I'm glad to be part of the Software Underground anyway. And I wish that I found out about you guys way earlier. Actually, I had no idea.
Great. So we're going to push on now. So I'm going to have to shuffle you out. There's been a slight change to the schedule as we haven't been able to get hold of our next speaker. So Matt's actually going to join us, and I think, do you want to speak about Transform, or should we have a little Q&A session with you, myself, and Brendon? It's your show, Matt, as I like to say.
No, I don't know. I'm like, I don't know. What do you want to do? We can do whatever we want.
So Matt, when did you found the Software Underground? Let's go right back to the beginning. You know, what was it? In two men in the back of a pub, like the original deep neural nets, or was it?
No, it was in 2014. So it was just after. So we did the first hackathon in Houston, in 2013, and Duncan Child came to that. He was a friend of mine. We worked together at ConocoPhillips. He was at Landmark at some point, and so was I. And then I think he was at SpectraSize at the time when we did this hackathon. And he was at nthought too. So it's so weird. So he's like, he was in a way, and he really got me into Python and coding for geoscience. And I can't remember how the conversation started, but we started a Google group. You remember those? Like an email list, basically, called Software Underground. And I think that maybe got up to about 50 people or so. I can't really remember. But then it moved, like, once we saw Slack, it was clear that it needed to move to Slack. And Duncan was around for a little while, but I haven't actually. I mean, he lives in Denver, I believe, and I haven't seen him for years. But he's not active anymore, unfortunately. Sure, he's still programming seismic geophysics all day long. Have you met him, Brendon? Not willing to say.
Yeah.
Sorry.
Oh, the guitar's
here.
moved.
Yeah, let me go live here, everyone. Sorry. So yeah, I actually met Duncan at I think AAPG last year. He came by and introduced himself, and I'd certainly heard about him, and it was good to meet him. Yeah.
So, and I mean, and it hasn't changed. Like it's been the same nerdy, Pythonish chat all the way through. But obviously, it got a lot more awesome once we moved to Slack. And I mean, the last few days have really just been such a great party. It's been a blast.
Yeah. So, question I think that I always have is, how often do people think you and Brendon are either brothers or related when you appear on the same call? For the record, then they're not. But I assume most people jump to that conclusion with their classifiers. If called Hall and Hall must be siblings.
Yeah, I don't know. I don't think anyone's ever. I've never caught anyone making that assumption to my face.
I forget who it was a couple of years ago at AAPG also, or something like that. Someone walked up and said, "Huh, I thought you would have a British accent for some reason." Like, I know why. No.
Yeah. I mean, if you train the model, you're both Canadian, you're both called Hall, you're both male. It all fits in the same,
Yeah. Except that Matt actually lives in Canada now, and I live in Houston. But
so Matt, I guess highlights from the last few days for you. There's been a lot going on. I mean, unsessions, tutorials. If you had to give some highlights or general or specific, what would they be?
Yeah, I mean, there's quite a few. I mean, I feel like for me at least, the hackathon sort of started more or less how I'd hoped it would start. Plenty of projects. I think there were 14 when I checked in on the first morning. Some of them very active already. But what's most thrilling about the hackathon is, and I can't remember, Brendon, maybe you can, quite how or why we decided to keep the hackathon going. But Filippo, I think Filippo was very keen on like keeping a thread going all the way through the week. And that's been just fantastic.
Yeah.
Because, the 2 days makes for a great hackathon live. And of course, it's what we have time for, kind of thing. But seeing those projects live through the week has just been really enthralling.
Yeah, I agree. I think that discussion came up when we decided to make when we made the call to make the hackathon virtual. And in discussing it, we had the opportunity to change things around. And at first it was like, well, it's nice to contain it to a weekend. It has that, that feeling of urgency. But actually leveraging, the digital tools we've been using to bring these groups together has had a really positive effect on the activities and how people can participate. Because you get a chance to drop into a couple projects actually and monitor them and have that conversation evolve over a kind of a longer period of time. So I think that's been good.
Yeah, exactly. I mean, totally. When we realized we were going to have to not do the hackathons that we were really looking forward to in Amsterdam and Houston, right? It was, at least I felt like, they're going to be online. That's like that's a step down. But actually, yeah, I totally agree with Brendon. We're starting to realize that if you can get away from the idea that online events are just rubbish versions of live events, that they can actually be something else and reach people in way more disparate places. Obviously, we haven't all had to travel somewhere, spend thousands of dollars, burn tons of carbon, and participate around our own days as well.
That's right.
Be at home, go for a run, have lunch, do the thing, still manage to chat with our friends and colleagues. And actually, Arthur said something on the first evening to me in the Hackathon Live. It was my evening. He's in South America, and he said, you know, I can't quote you exactly, Arthur, but I'll paraphrase. It was something like, actually, this online environment means that I can meet people and make a deeper connection right away, because we're immediately hacking on something and talking about stuff that we love. So I really liked that.
Yeah.
You know, if that's the only thing that comes out of it, I think that's a
So
fantastic
Matt, how do we make it last? That's my question, because I know people will be clawing to get back into face-to-face and the wining and dining, and you know, I mean, obviously we'd all rather be in the French chateau with piles of cheese and wine as rather than in our various.
I wore my Transform 2019 T-shirt in solidarity, everyone. So
nice.
Yeah, but
I have my London hack. Just FYI.
Yeah.
I think you made this, right, Dan?
I did. Yeah. It's
yeah. I mean, I don't know what happens next, but like just chatting with Gerard earlier, actually, just briefly after the DeVito tutorial, and you know, often in the past we've shown up at SEG in the fall, so you know, October-ish, and done hackathons there, and the Repro Zoo, and the first Geophysics Sprint a couple of years ago, and stuff like that. So that's, you know, a bit of a time for us now. You know, we've also got this field camp thing planned for October, which may or may not be able to happen as is. But I'm thinking that if field camp can't happen, then maybe we can expand that into an online event, or we add some other kind of online event for the autumn.
Sorry, I just hit a button. That was my.
And what maybe if distancing rules and such allow us, then, you know, come October, it would be really cool to see sort of little pods of people in places like Stavanger, Houston, London, you know, Perth, where, you know, where we already know there are meetup groups and lots of Swung members. I'd love to see what a sort of hybrid online face-to-face thing looks like.
Yeah, it's interesting because I work cross-border a lot with Aberdeen, and there's a lot of toing and froing there for what I'd say is very little actual result. So I'd love to do a cross-border, you know, okay, Aberdeen, Stavanger collaborate. Maybe we meet on the Orkneys at the end of it, but yeah, I think that's a great idea of getting these hybrid events and local pods of self-organizing networks. Funnily enough,
absolutely.
At one of the hacks, we had Lucas was in Athens or somewhere, and we were corresponding with him from Stavanger, saying, "Can you help us with the unsupervised stuff?" You know, so it definitely happens. If Nathan's there, I think we can get back on track for our last couple of speakers for today. But thanks, Matt, for jumping in and filling the gap. I think it's actually a really great lightning talk to have, just about transform life and the future of geoscience.
Yeah, right. Well, thanks. Thanks for all this too, Dan, and I'll see you guys
when
later.
you said I would just have to introduce the speakers and turn up, that was a bit of an understatement, Matt, but I'll forgive you.
It's my specialty. Quietly reserved. See you later.
See ya. Cool.
All right, can everybody hear me?
Yeah, we can hear you loud and clear. I'm gonna just hand straight over to you, as we are. Actually, we've got 2 minutes. So how are you today, Nathaniel? You good? Nathan?
I'm doing great. It's nice day here in California. I think it's gonna be a little bit hot where I'm at, but it's great.
Yeah. Cool. It's actually turned here in Stavanger to rather nice sunshine, which is a little bit rare. It's good. So do you want to just give a bit of a background on how long you've been in Swung, how you came to decide to do a lightning talk, I guess?
Okay, I kind of got hooked up with Swung 2 years ago, participating in a hackathon in Stavanger that was put on by the Norwegian Petroleum Directorate. Met Matt there, and then kind of as I went to conferences later that year, I kept running into Matt just kind of randomly at conferences and stuff, and participated in like that AAPG unsession in Salt Lake. And so it's been nice to kind of have regular contact with Matt and the Agile folks and Brendon, a bunch of other folks that are kind of tied to the community as well. As far as the lightning talk goes, when they called for lightning talks, I thought, you know, there's lots of things that I'm doing geoscience related for work. So I thought, well, surely amongst all that, I can come up with 5 minutes of something to talk about. And
No, I remember you from that Stavanger hack as the man with the millions of well logs from California.
Yes.
Yeah.
Yeah.
So, and I'm not going to delay you any longer. Take it
Okay.
away.
All right. So given the informal nature of this, I wanted to talk about just something that really helped me. You know, I've been doing some level of programming as part of school and work for about, I don't know, 11 years now in various languages. And I think of all the concepts that have helped me the most in my journey to becoming a more professional programmer type has been just kind of understanding this concept of abstraction. Like you could kind of wax philosophical about it. I'll go ahead and go to this next thing here. Just I always like XKCDs, but what's really neat about abstraction is it's one of those concepts that kind of underlies really civilization, and you don't really realize it necessarily what it's doing. But today I'm going to kind of focus narrowly on just how it affects code. But you know, abstraction really affects language, writing, all kinds of things that we rely on, and it's really, you know, we talk about agile code and agile programming structures and wanting to be flexible with our code. And yet all too often we fail at it. And sometimes we don't understand why we fail at making our code agile and flexible and modular and all these things we aspire to. So what I want to talk about is dependencies and how abstraction helps with that. So I've got this little code thing over here. I don't know if you can see my mouse, but code thing here. And so dependency is something that depends on that first code thing. It could be, you know, something next thing in your pipeline. It could be some function you wrote to take data. It could be really anything that uses that code thing. And when you have one code thing depending on another code thing, you know, it's not too bad. It's if you need to make a change to that first piece of code, it's really easy to make the change because you only have one place to go to update to handle that change. But what really gets crazy is when you start building up, you know, everybody does this, you know, a code kind of accretes more and more code as you get more requests and more people asking for things or wanting to add new features. And pretty soon that first code thing that you started with has, you know, dozens, hundreds, maybe even thousands of things depending on it. And so what happens is you want to go back and make a change or fix a bug or something in that first code thing that you wrote. And it's nearly impossible. There's too many things tied back to that first thing of code because you have to go to all these downstream things and check for bugs and think, you know, and assumptions that you made depending on that code that have changed. And that's not agile. It causes your code to become kind of really inflexible and hard to change. And it's frustrating because you want to be able to respond to change. That's agile coding. So, you know, programmers, you know, anybody that's taken computer science has probably been introduced to this idea of dependency, inversion, or abstraction. But hopefully I can kind of give a really basic example of this to everybody that's kind of new to this journey. And so the idea of a dependency inversion is that you kind of put like a firewall or a break in the dependency chain in your pipeline so that the hard dependencies on something in that first bit of code stop in one place and don't propagate further down into your code. And basically, when you boil down what is abstraction, it's an idea. It's the definition of something. Like in the code sense, it's you're codifying an idea of something. And let me give an example of that. So all geoscientists are at some point are going to deal with some kind of pick, whether it's a horizon pick or, you know, a geologic pick on a petrophysical log. And so here in my code, I'm making a data frame of some pick database. Very simple. It's just three picks in 2 wells. And you know, I've got it displayed there. And so I've made this function called sum picks for well process. It's just going to sum the measured depths of all the picks in a well. Really simple. I want you to think of this as kind of a stand-in for whatever complicated pipeline or processes that you're going to build that uses these picks. It could be thousands of lines. It doesn't matter. This is a stand-in for that. So you run this function. It sums the picks. Everybody's happy. You're done. Move on to the next thing. but everybody has this happen. Somebody comes to you, hi, we just bought a field. Could you use your amazing script process that you just wrote on my field that we just bought? They sent us this this Excel file with the picks. And so here's the new pick data frame. Here's what it looks like. You're like, sure, we can run this on this. And so you go and you run your process, and you get a huge stack of errors. Let's see if I can, it's not going to print the errors for us. But basically, it doesn't work. You get errors, because fundamentally, this pick data frame isn't the same as the other one. And your code, your process is dependent on the format and shape of that original data set you built your code on. So how do you handle this? So in this case, it's really simple. You build some kind of column cleaner type thing that defines an abstraction, right? The abstraction is, this is what a pick database should look like. This is what the different pieces of data should be called. And then once you've built that abstraction, it's really easy to extend it to cover new formats of picks that come in from other people. And all of your downstream code depends then on that idea of what a clean pick database looks like, right? So it's really simple. That's an example of an abstraction. And in that case, there's lots of ways you can implement that abstraction. If you're a database programmer, maybe you make a view that turns all of the various pick databases into one database that looks the same or something like that. But the idea is that if you don't do that, if you just keep importing dependencies from new sources, then your validation code is going to start springing up and multiplying like rabbits within your code, and it becomes very difficult to manage. I'm out of time, but there's one other example you could bring, which is third-party libraries. When you bring in a third-party library to your code, it's kind of the same situation. Like that third-party library doesn't know about you, may not care about you unless you know them personally, and they can make changes to their code that'll break your code. And how do you handle that? Well, you put an abstraction between you and them so that you gain flexibility. But anyway, if anybody wants to talk about it, we can move this to Slack, and if you have questions. So.
Great. Oh, thanks. Thanks for the concept of abstraction. It's always interesting to think of the pipeline debt you create by coding a lot and creating products. Yeah. So I'm going to ask you the same closeout question: is this week? What's caught your attention? What's really have you been hacking on anything, or is there anything big going on?
Yeah, I've been working with Justin on the IOVIS hack. I'm really interested in, I've been trying to get into JavaScript more. Most of the languages I've learned are like C or Swift or Python or R. And so JavaScript with the browser-based coding is different and interesting and important in terms of being able to create portable web views of your work. So.
Yeah, I think that's my big takeaway from this transform is JavaScript is where I think I need to head next. It's always put me off, but based on the talks I've heard, I don't think I need to be scared anymore. Yeah. So, but thanks again for the great talk. Feel free to catch Nathan on the Software Underground. And good luck with the rest of the hack. I'm just going to shuffle you back into the waiting room and bring in last but by no means least, Mr. Steve Purves with his talk on JavaScript. I've known Steve quite a while now, and I'm really looking forward to hearing what he has to say. So. Hello, Steve. Good afternoon, I guess. Steve Purves with his talk on JavaScript. It's me.
Hey.
How's it going? Nice to see the whiteboard in use.
Yes.
All your work, or has Charlie been involved?
No, unfortunately, just me. It would be bad if Charlie.
Great. And which hackathon t-shirt are you sporting, just to round the set out?
This is the GAN generated.
Ooh la la. Yeah. So how are you? How are things in Tenerife? We got 1 minute for you to give us a quick pitch.
I'm good. Things have been busy, and I'm just watching the live stream 2 seconds behind on my left. Things have been good. This week's been great. I haven't managed to participate or watch as much as I wanted to, but we've got it all recorded, so I'm going to go and spend my evenings.
Yeah, I look forward to watching my footage back and cringing at my bad jokes and emceeing. But anyway, I'm eating into your time to talk about your journey into JavaScript. So without further ado, Steve, the floor is yours.
Okay, let's share my screen. So this talk was a product of myself having a little chat with, oh no, I don't want to share it, with Justin, who's also talked on exactly the same subject. And we thought it was interesting, well, what if two talks were independently put together on the same subject? So this is my take on JavaScript from GeoPythonistas, which will be very different from Justin's, I think. So, first of all, I love coding in JavaScript. JavaScript is powerful and it's really fun to use. The caveat on that is that fun level varies depending on what you're trying to do, where you're working, and not in terms of the place, in terms of the code you're working with, the environment you're working in. And things can be more or less difficult depending on the constraints that are put on you. But the language itself has improved hugely over the last 10 years, and now is a really flexible and lovely language to work in. So, I mean, as a GeoPythonista, I imagine they might be trying to do one of three things. Maybe you're trying to create a custom component from a framework like Bokeh, which gives you just a little window within which you need to slot in JavaScript code. Then you're really constrained because you have to put exactly what Bokeh wants into that slot and follow its patterns. Or you might be writing a Flask app, and you're doing server-side rendering, and there's some JavaScript injected to the page to do some of the interactivity done there. You've got a bit more flexibility there, but again, it depends on what your server-side rendering build setup is like. Or right at the other end of the scale, and maximum fun, is when you're building out a rich front-end web app from pure JavaScript, which I think a lot of the things that we prototype really need to go there, because that's where a lot of the interactivity is. That's where you make really good user experiences, and that's actually what's the most fun to code. So the fun increases proportionally with the ability to use modern JavaScript, is the premise. Now, what do I mean about modern JavaScript? Well, this is an example of not modern JavaScript, and this is the JavaScript we'd be writing typically if you were maybe writing a custom Bokeh element, or writing JavaScript that was just to go straight on the page. It would be low level, not use much functionality so that most browsers supported it. And it would be very heavily tied into the DOM. You can see here we're getting elements and then node names. We're asking the document and we're querying selectors. To work with JavaScript like this, you need to know the DOM object model inside out. And it can be quite frustrating and painful if you don't. Modern JavaScript, though, has evolved hugely through various iterations with various names. These days, we generally say, oh, well, we're on version EC 2005 or EC 2019, where more and more rich features have been added that really brings it up to something that is close to Python in its sort of the way you can write readable code, manipulate data structures, and so on, and do some other things that are particularly difficult in Python. You can do them more easily in JavaScript. So, just noticing from interacting with people who code in Python and do bits of JavaScript, one of the big conceptual steps to get over is your environment is no longer here. You're no longer in your conv env, but your environment instead is out there. And so when front-end developers are writing these custom apps these days, they tend to think they're trying to, in order to stay productive, they stay distance from that environment out there. They decide on it, but then they step back into a nice, cozy build environment where they can use all this lovely modern JavaScript. And they work writing that code, and then the JavaScript actually gets transpiled, which is a bit like compiling, but it actually gets transpiled to the version of JavaScript that those browsers will support. So you can protect yourself from that ugliness. And that's a trend, that's good, because it's also these transpilers and these build systems have been built up by smart people, and they polyfill and patch and make up for all sorts of quirks in the different browsers. So all that work's done for you, and you can get on with writing app interactivity, writing business logic in a nice language. You don't have to go that far. If you are writing some code, like you might be on the IOVIS project at the moment, and where there's no build system like that, I believe. But still you want to be able to use some richer language features. You can I use, I'll correct that, is a website that I think all web developers use that lets them look at a given feature. For example, here, the await keyword in JavaScript. We can see what level of browser support there is for that. And if that support's high enough, well, you can just go and use that feature in your library, and you'll support all the browsers that you want to. So there is the options to use modern JavaScript inside sort of other small libraries, or where you don't have this build system. So I just wanted to give as well. So that was a bit of context, and I think I just went through that because I think that's a gap that most people don't realize, that when big apps are getting built, they don't do it the same way as we're doing it when we're doing small changes or writing custom components. It's different. But when you can go to modern JavaScript, you get this lovely language to deal with. And I've got 3 best bits that I like that you might recognize from Python as well. The first bit is destructuring. So we can take any complex object, this one's not that complex, but any complex object, we can take it and we can assign it to a constant. And a little bit like when we unpack our tuples in Python, we can reach in and just pop out individual elements of that. I use that all the time to be able to reach into a response from a server and just pluck out the bodies. It also works on arrays in JavaScript as well. So we can take a big array and we can destructure it into a small array, and we can mop up anything that we haven't targeted in using this syntax and stick that in a variable called rest. So this is a great feature that I use a lot. The spread operator, which is those 3 dots that we just saw. So the spread operator works a little bit like the star and the double star in Python. That allows us to define a function. So if we have a function with many arguments, for example, we can come along and we can spread other arguments into it. So then when we get an object, we don't have to go through typing out or extracting all the parts and passing them to the function. You can just go in and spread the object in, which makes things a lot more compact. But on the other way around, we can also use the spread operator to mop up arguments. This is a bit like doing star args on a function definition in Python. So there are parallels, and some of that compact coding we get and flexibility we get from Python is also available here in JavaScript. What I don't think is available on, which is also available on Python, is also the spread operator applies to objects. So here we have an object, and here we're creating a new object B, which is a shallow copy of A, and I've also overridden the property B. So if we were to go and print out object B, we'd then have this with a modified property. Seems simple, but this pattern is a huge pattern that allows you to write functions without side effects using very concise code, because you can bring in an object, basically clone it with this line, modify it, and then the outgoing object is a new object. So your function's pure. And you can do the same thing with keyword args and apply double stars to dicts and Python. I don't see it done often, but that's the same pattern where you can get away without having side effects, but with very compact code. The last bit of JavaScript, which I think it does better than Python, is the handling of asynchronous tasks. Now, previously, JavaScript would make you do lots of nesting. You have to pass callbacks into things to handle asynchronous tasks. Now, with the use of the async await keywords, we can write an async function and have it await some other function that goes up in the client and get my images. And then in my app code, I can go and await it. And JavaScript does some magic here in terms of it will pause the execution of that function until your code is, until the call returns, go off and do some other stuff, and then it'll drop you back in here. So you can basically write sequential code, but handling asynchronous communication, which is excellent. And I don't think Python's quite there yet. I mean, the deferred things, the future things is close, but it's a bit more clunky. So to sum up, JavaScript is powerful and fun, but your fun level may vary. And if there's one thing to do after this presentation, it would be to head over to the Well.io Viz project on Slack, see what they're doing, and play around with some well logs in JavaScript.
Thanks, Steve. Great to hear from you on the kind of what Python and Java do different. Yeah, and thanks for closing off day one with such a great talk. That is the end of our scheduled lightning talks today. We'll be back starting at the same time tomorrow with a whole bunch of new speakers and topics. And yeah, thanks to Matt for organizing it, Brendon for being the invisible man who's been pulling all the strings behind the scenes. You got to see him briefly, so I'm glad you went noticed. And again, to all our speakers. Yeah, I don't think we've got anything else to add, have we?
Great. No, I think that's it, Dan. Just want to say thanks everyone for tuning in. We've got 3 tutorials starting in about 3 hours. So some great content coming right up, and then more of all of this tomorrow as well. So we are looking forward to seeing everybody then.
Great. And yeah, any questions, follow up with the speakers. It seems there's a lot of interest in lightning talks. So if we want to start organizing them, then do let me know and I'll see what we can put together. But thanks everyone and have a great evening or afternoon or morning, depending on where you are.
And we're done. We're out.